similar triangles, try this section. It is not part of any exercise as such, but it is mentioned as try this section in the textbook. The problems are mostly about similarity of triangles. We need to find if given two triangles are similar or not. If so, we need to name the criteria of similarity and also write the similarity relation in symbolic form. Question number 1. Here, two triangles are formed due to intersection of lines AD and BC between two parallel lines AB and CD. Since no angle is given, we will try to explore the angles using these parallel lines and intersecting lines. Here, there are two types of angles formed because of these parallel lines and the two intersecting lines. The angles formed due to intersection of lines AD and BC are known as vertical angles. That means angle at AHB and angle CHD are known as vertical angles. Similarly, angles formed at B and C, that means angle ABH and angle HCD, are known as alternate angles. Similarly, angles formed at A and D are alternate angles. So when alternate angles are formed between two parallel lines, they will always be equal. It means angle B would be equal to angle C. Likewise, angle A would be equal to angle D. So two of the angles in both the triangles are of the same value. That means angle B and C are of the same value and angle A and angle D are of the same value. In addition to that, the vertical angles formed due to intersection of lines AD and BC would also be of same value. So now all three angle combination is same for both the triangles. Both the triangles are sharing the same set of angles. These triangles are similar. And the criteria can be called as AA similarity or AAA similarity. Means all angles, corresponding angles in both the triangles are of same value. To understand the angles between two parallel lines like alternate angles and vertical angles, let us measure these actual angles and try to understand their relationship. So if you see AB and CD are parallel lines, so AB and CD are parallel lines. AD is a line connecting these two parallel lines and forms alternate angles at D and A. Both alternate angles angle D and angle A are of the same value. Likewise, BC is a line connecting two parallel lines and forming angles at B and C. Again, these two alternate angles are also of the same value. The vertical angles formed due to intersection of lines AD and BC are also of same value. So as long as AB and CD remains parallel, the alternate angles would always be same, whereas vertical angles would anyway be of the same value. This property of the angles between parallel lines is very much useful in solving problems in similar triangles. Question number 2. Here, no angles are given for both the triangles, though it appears that PQ and LM are perpendicular to their bases. We cannot assume because it is not explicitly mentioned in the problem. So we can only find the similarity of these triangles only using side lengths. So if you take the ratio of corresponding sides in both the triangles, PQ is the shortest side and LM is the shortest side in their respective triangles. So if you take the ratio of PQ to LM, it will be 6 by 3, which is equal to 2, 6 by 3. Now take the ratio of the remaining sides, which are QR and MN, for which the side lengths are given. If you take the ratio of QR to MN, it is 10 to 4. So the value is 2.5. So earlier ratio of PQ and LM was 2, whereas ratio of QR and MN is 2.5. So the ratios are not same for the respective sides in both the triangles. Hence, these two triangles cannot be similar. Question number 3. Here, there are two triangles AXY and ABC, as if they are superimposed on top of the other. So angle A is same for both the triangles ABC and AXY, and side lengths are given for two of the sides. That is AX, which is 2 units, AY is 2 units. Coming to triangle ABC, side length of AB is 2 plus 3, which is 5 units, and length of AC is also 2 plus 3, which is 5 units. Since we know one angle and two sides, let us try SIS criteria to see if these two triangles are similar or not. So for that, angle is anyway same and its adjoining sides, which are AX, AY for triangle AXY and AB and AC for triangle ABC. So if you take the ratio of AX and AB, which is 2 by 5. Similarly, if you take the ratio of AY to AC, this is also 2 by 2 plus 3, which is 2 by 5. So corresponding sides ratios are same for the sides AXAB and AYAC in both the triangles. Also, the included angle between those corresponding sides, which is angle A, is same for both the triangles. So these two triangles are similar based on SAS similarity. Apart from that, notice that XY is dividing AB in the ratio of 2 to 3. The same XY is also dividing line AC or side AC in the ratio 2 to 3. It means that as per Thales theorem or basic proportionality theorem, when a line divides two of the sides in a triangle in equal ratio, that means both sides in equal ratio. This side 2 is to 3 and this side 2 is to 3. Then the line must be parallel to the third side of the triangle, which is BC. So XY must be parallel to BC as per Thales theorem or basic proportionality theorem. So when XY is parallel to BC, you may notice that angle B should be equal to angle X. Likewise, angle C should be equal to angle Y because XY and BC are parallel lines. So that way you could see that all three corresponding angles of both the triangles are same. And hence the triangles AXY and ABC are similar. Question number 4. Here the triangles to be considered are APJ and ABC. The length of AP is 3 units, whereas length of AB is 3 plus 5, which is 8 units. Similarly, length of AJ is 2 units and length of AC would be 2 plus 10 by 3, which is 16 by 3. Angle at A would be same for both the triangles ABC and APJ. It means angle BAC is same as angle PAJ. So one angle is same and lengths of two of its sides for both the triangles are given. Let us apply SA similarity criteria for these two triangles to find out whether they are similar or not. So to find the corresponding sides of the triangle ABC and APJ, take the sides AP and AB. If you take their ratio, AP by AB would be 3 by 8. Similarly, if you take the ratio of corresponding sides, if you take the ratio of corresponding sides adjoining angle A, that are AJ and AC, AJ is of 2 units and AC is of 2 plus 10 by 3, which is 16 by 3 units. So now you take the ratio of AJ to AC, it will be 6 to 16. So the earlier ratio of AP to AB was 3 by 8 and the ratio of AJ to AC is 6 by 16, and both are of same value, because if you cancel 6 and 16 using 2, it would be again 3 by 8. So the included angle at A is also same. So it follows the SAS similarity criteria. So both the triangles are similar because they are having same angle. One of their angles is same, and the sides adjoining to those angles are proportional. Also, because PJ, which is a line intersecting sides AB and CD with the ratios of 3 to 8 on both sides. This side 3 to 8 and this side also 3 to 8. PJ must be parallel to BC. Again, when PJ is parallel to BC, angle P must be equal to angle B and angle J must be equal to angle C. In which case, all three angles are same across two triangles. So all corresponding angles are same, means we can use AAA criteria also to say that these two triangles APJ and ABC are similar. Question number 5. Here there are two triangles AQO and OPB. Both the triangles are having one angle common, like angle at A and angle B, which are of the same value, which is 90 degrees. Also, angles at AOQ should be equal to angle POB. Question number 5. Here there are two triangles which are AQO and OPB. Angle at A is equal to angle at B. Also, angles at O for both the triangles should be same because line AB is intersecting line QP. As you could see here, if two of the lines intersect each other, the vertical angles formed at the intersection would always be same, no matter how they intersect and where they intersect. So the angle AOQ must be same as angle POB. So now two of the angles in both the triangle are having same values. When two of the angles are same across both the triangles, the third angle value must be also same for both the triangles. It means angle Q must be equal to angle P, because in a triangle, sum of all three angles must be equal to 180 degrees. Since we know other two angles in both the triangles, the third angle, which is Q and P in both the triangles, must be of the same value. So now, given both the triangles are having same set of angles, we can call these two triangles similar based on angle-angle similarity, or all three angles, means AAA similarity. Question number 6. Here, triangles ABC and PQR. Both the triangles are having same set of angles, means 40, 60, 80 and 40, 60, 80 degrees. So you can straight away say that they they are similar because all three respective corresponding angles in both the triangles are of same value. So you can take this as angle similarity criteria and say that these triangles are similar. Question number 7. Two triangles ABC and PQR. None of the angles in both the triangles are given. Only side lengths are given for both the triangles and for all sides. So if you take the only so the only way we can establish a similarity relationship between these two triangles is using sides. So let us try SSS similarity criteria to see if they are similar. SSS means all three corresponding sides of both the triangles should be of the same ratio. It means if you take the corresponding sides, means the long first we will start with the longest side. The longest side in PQR is PR and the longest side in ABC is AC. So if you take the ratio of AC to PR, it would be 3 by 6. Likewise, the shortest side in triangle PQR is QR. If you look at the shortest side in ABC, both AB and BC are of the same value. So you can take either BC or AC, AB as the shortest side. So if you take the ratio of QR to its corresponding side BC, which is 4 divided by 2, or if you take it otherwise, because earlier we took 3 to 6 means we started from ABC to PQR. We took the ratio of AC to PR. Now this time we take ratio of BC to QR. It would be 2 by 4. So 2 by 4 is equal to 3 by 6. What about the sides, remaining sides, which are AB and PQ? If you take their ratio starting with ABC to PQR, AB to PQ is 2 divided by 5, which is not equal to the ratio of other corresponding sides. So, comparing the sides, we can say that these two triangles are not similar. Question number 8. Triangles ABC and PQR. Angle A is equal to angle B, which is 70 degrees. Lengths of two of the sides in both the triangles are given. For AB 6 units, AC 10 units, PQ is 2.5 units and PR is 5 units. Since one angle and two of the sides are known in each of the triangle, we can apply SAS similarity criteria. So if you take the ratio of the corresponding sides adjoining this angle which is 70 degrees in both the triangles, the corresponding side AB, which is the shortest side in triangle ABC, corresponds to side PQ, which is again shortest side when compare two of its sides in triangle PQR. So 6 by 2.5 is one ratio and the other ratio is longest side in triangle ABC is 10 centimeters and longest side in triangle PQR is 5 centimeters. If you take the ratio, it is 10 by 5, which is 2. But earlier ratio was 6 by 2.5, that of AB to PQ. So the ratios of these corresponding sides in both the triangles adjoining the angle A and P are not the same. So SAS criteria is failing for these two triangles. So these two triangles are not similar.